alkenes have carbon-to-carbon double bonds, which is known as unsaturated. The carbon-to-carbon double bond can break and substances can add on to the alkene to form a new product. This is known as an addition reaction. The first type of addition reaction that we're going to look at with alkenes is the addition of hydrogen, which is known as hydrogenation or hydrogenation. So let's take ethene, which has an unsaturated carbon-to-carbon double bond. We're going to add a molecule of hydrogen, which is a diatomic molecule. And what will happen is the carbon-to-carbon bond will break and a single hydrogen atom will add to each of the carbons which contain the carbon-to-carbon double bond. We can see now that we have saturated carbon-to-carbon single bonds, which means that this is known as ethane. Alkenes can react with hydrogen to form alkanes. We need to be able to take this and write the molecular formula for this. So we would have C2H4 plus H2 goes to C2H6. So here's one for you to have a go at. So if you want to pause the video, you can have a go at drawing the full structural formula, identifying the name of the product, and converting this into your molecular formula. So when we draw propene, remember prop tells us that we have 3 carbons and we've got a carbon-to-carbon double bond. We add on hydrogen. What happens is the carbon-to-carbon double bond breaks and a hydrogen adds to each of the carbon atoms. This is now saturated, it's got carbon-to-carbon single bonds. So the name of the product produced is propane. To write this in the molecular formula, we have C3H6 plus H2 goes to C3H8. Alkenes can undergo a second type of addition reaction known as halogenation or halogenation. Group 7 elements are known as the halogens. We have fluorine, chlorine, bromine and iodine, and these are all diatomic molecules. If we were to add these on to an alkene, the name of the branch would be known as fluoro, chloro, bromo, or iodo. We need to know that the test for unsaturation is that it decolorizes bromine solution. Alkenes can react with a halogen to form dihaloalkanes. So let's take this first example where we have ethene and we add in chlorine, which is a diatomic molecule. What happens is the carbon-to-carbon double bond breaks and a single chlorine atom adds to each of the carbon atoms that had the carbon-to-carbon double bond. We can see that this is now saturated carbon-to-carbon single bonds. So to name this would be known as 1,2-dichloroethane. To change this into the molecular formula, it would be C2H4 plus Cl2 goes to C2H4Cl2. So if you want to pause the video, you can have a go. And when you're ready, you can press resume and the answers will come up on the screen. So we have but2ene and we add fluorine. The carbon-to-carbon double bond breaks and a single fluorine adds to each of the carbons which had the carbon-to-carbon double bond. This is now saturated, so it has carbon-to-carbon single bonds. So the name of this new product would be 2,3-difluorobutane. If we were to change this into the molecular formula, it would be C4H8 plus F2 goes to C4H8F2. So if you want to pause the video, you can have a go at naming and drawing the full structural formula for the examples given. And when you're ready, press resume and the answers will pop up in the screen. This past paper questions from the National 5, 2019, written 5A. The alkenes are a family of unsaturated hydrocarbons. Describe the chemical test, including the result, to show that a hydrocarbon is unsaturated. The test for unsaturation is that it decolorises bromine solution. This past paper questions from the National 5, 2016, written 8C Part 2. Limonene C10H16 is an essential oil which is added to some cleaning products to give them a lemon scent. The concentration of limonene present in a cleaning product can be determined by titrating with bromine solution. Write the molecular formula for the product formed when limonene reacts completely with bromine solution. So the first thing that we have to do is look for the carbon-to-carbon double bonds. As limonene ends in -ene, we can see that we have 2 carbon-to-carbon double bonds, which means 2 addition reactions can take place. So if we have C10H16 plus 2Br2, that means that the molecular formula for the product would be C10H16Br4. This past paper questions from the National 5, 2019, written 5B Part 1. Propene is an alkene that can take part in a range of addition reactions. Name the type of addition reaction taking place in reaction Z. If we put a circle around the things that have changed and been added on, we can see that we've added 2 hydrogen atoms, which means that the name of the type of addition reaction is hydrogenation. Part 2 to the same paper asks us to name the chemical that reacts with propene to form compound Y. Again, we want to identify what's new on compound Y. We can see that we have added 2 chlorine atoms. So the name of the chemical that reacts with propene is chlorine, which is Cl2.